Now we are going to talk about 1.6 and review of power function, polynomial function, and rational functions. So with the appetizer portion, let's see what those functions are. So when you see power function has a form of y is equal to p of x to the n. So you will see that power function will be always one term, and then it will have most time x values, and then p and n is going to be constant. So which can be any numbers. Then what is a polynomial? When you put all the power functions together, then it becomes a polynomial. Then we write a polynomial as a of n over x over n plus a of n minus 1, x over n minus 1, all the way to the last constant c, if it exists. If I give you an example of a polynomial function, you guys see lots of quadratic functions. These are polynomials, as you see addition of the power functions. So if you want to see the power function, that is going to look like this way, or like 3x to the pi, that's okay to use. So these are all power function examples. Power function, when you put them together, it can be polynomials. One thing that you have to be careful, polynomials, your n has to be non-negative integer. So you have to use integer value here. Then what is a rational function? Rational function is going to look like 1 over x, right? So these are rational functions when x is in denominators. And example will be this one, or it can be also 1 over x squared. Another way also saying rational function is you put in polynomial over polynomial. That can be also one of the way we can describe as rational functions. Then let's look at example of A, B, C, if you can distinguish if these are power function, polynomial function, or rational functions. So think about the definition I briefly explained to you. And first one, when you see it, what kind of function does it look like? This is a polynomial. How about next one? This will be power function, because I can write it as a power 1 over 2. So it's a power function. But cannot be polynomial because your power is not integer. And then C is going to be rational function. As you see, these are this over this with your polynomial functions. Then let's have our appetizer example 1. Example 1, I want you to actually think about power function when it has an odd degree. So example, odd degree will be this. These are the odd degrees. So if I graph carefully, my graph 1 of y is equal to x, I'm going to have a linear function. And then careful, when we do x cubed, it's going to pass through these 3 coordinates, but my graph is going to be look like chair shape. That's what we say as a chair shape. Then when you have x to the 5th, what are the differences? These are about shape is the same. However, also it still passes those 3, but you have to see the graph. It's going to increase faster as x to the 5th power. So your graph will be actually increasing faster. Then one part that you have to be careful in calculus class is this part. If you're staring at it, let's compare y is equal to x to y is equal to x to the cube. As you see, the x to the cube will increase 3 times faster because we cubed it. However, when you, not 3 times, triple times faster. However, when you look at the graph carefully, 0 to actually 1, if you clearly see your graph is going to look like this way. So from 0 to 1, actually your x cubed graph is smaller than x. But after you going bigger than 1 as your domain, you see that it's going to be changed. Now after 1, your x cubed is going to be dominant the linear equations. So let's talk about next one. Now it's in class activities. If you want, pause the video and then try to see even degree power functions. I will give you example of even degree power function will be x squared, x to the 4th, x to the 10th, x to the 20th. These are going to be all even degree power function. So we know that our quadratic function looks like smile face. So I'm going to draw my smile face here and then passing through these coordinates. Then what are the differences? Their shape is actually about the same as a parabola, but there will be slight differences again. So if I graph x to the 4th or x to the 20th, the graph will still pass through these 3 coordinates, but it's gonna be a little bit steeper, and then your U shape will be a little bit more cornered. So same reason, if you say x squared to x to the fourth, I know that x to the fourth power will increase faster. However, that's gonna be only happening after 1. When you have your value between -1 to 1, your x to the fourth power will be smaller value than x squared value. So you cannot always say that everywhere my function will be greater because your power is bigger. Now since you're in calculus class, we have to be a little bit analytical and tedious. So this is the addition part of from your pre-calc, and then try to see that what graph is dominant. I can say that from 0 to 1, my x squared is going to be dominant because of your black color graph is bigger. But once it's bigger than 1 as your domain, your x to the fourth power graph is going to be bigger than, dominant than x squared function. So that's a little bit part of the calculus today, and then let's continue next question. Well, let's look at example 2 of the appetizer part. Look at the graph given and try to find the possible equation or formula for given functions. So when you see this one, it looks like x to the fourth power, right? And also I'm going to have 3 zeros. So from here, I can see that one of my factor will be x minus 2, plus 2, and then this will give me x squared. Do you see that? Looks like x squared shape. And then there's a noise transformation, so it will be just x squared, and this makes x minus 2, and we are having open up graph, so your a value is going to be positive, or you can just write it as a, which is fine with me, or you can put it without a, that's okay. Then let's look at next one. This will have x cubed as my leading power. Earlier one was the x to the fourth power. How you know? 1, 2, 3, 4. This was 1, 2, 3. So I'm going to have 3 zeros, but here, do you guys also see again x squared shape? So that's going to be x squared, and then this is going to be x minus 2 as my intersection, and then y value. However, I see that my graph is upside down, so you want to put negative in front of it. Careful about the negative. And then now in class activities, I want you to try quickly and compare the answer with me. So I got the answer of this one. If you see, I have my x-intercept at -2, so I must have a factor x plus 2, and then zeros. As you see, it doesn't look like x, it looks like x cubed, so I put actually x cubed. Young, can I put x to the fifth? Yeah, you can put x to the fifth. This one looks like to me x to the fourth power, or it could be x to the sixth power, depending on, as you see, x to the fifth power also has that shape like chair. So check the answer with me. Okay, so now let's start the main dish, example 3. So now using the function given, and we are going to graph the functions. Earlier we talked about the shape here. So this one, I see that degree 1, degree 3, degree 1. So total is going to look like x to the fifth power. The shape is going to look like something like this way. And I see 1 0 at 0, 3 zeros at 3. So that's going to look like this shape. And then 1 0 and -2. So let's see that at 3, it is going to have a chair shape. And then at 0, it's going to cross like a linear. And then at 2, it's going to go also down. So without, if you look this way, it looks like x cubed. But if you carefully look at, this will make it cubed function of x minus 3. Then one more practice. I have x minus 3, x plus 2. So my zeros are zeros, 3s, and -2. However, this will cross, this will touch, this will cross, and my leading power looks like x to the fourth with the 1, 2, 1 total power over 4. So my shape will be something like this way. However, at 3, it's going to be touching like a parabola. So my graph shape will be looking this way. Okay, now again, I want you to quickly pause it and then try your in-class activities. Okay, So that's the shape I got. As you see, at x minus 3 has to be parabola shape, and x plus 2 also parabola shape, but leading power is x to the fifth power is positive, so my graph is going to look like this shape. So you can try. Okay, so let's move on to example 4. And that's the analytical part of our function, comparing x cubed compared with 2 to the x. So which function do you think is gonna increase faster between this one and this one? And as we studied, also we heard about coronavirus, exponential function is definitely more powerful. So if you graph this one, graph will be definitely starting at 1, and then the graph is gonna increase exponentially. Then let's graph 3 to the third power. Then my graph starting from 0, and then the shape of the graph is going to look like chair shape. Oh, I should graph really good. So roughly it's going to look like this way. So when you look at the big picture, definitely you will see that 2 to the x is dominant, definitely. But as you see, depending on where it is. So if you look at your textbook, it breaks it down by your interval. If you're looking at between 0 through 1, then you see that your exponential function is definitely dominant. So here, 2 to the x function is bigger than x cubed function. Then if you zoom out your interval of x to the 10, then there will be another intersection meeting. Sorry, I don't have a calculator and then showing this number right now. So there will be about, if you plug in 9 something, then there will be another intersection. And that time between 1 to the intersection, I see that my x cubed is dominant. Then after interval 10, around that number, and rest of them, definitely 2 to the x graph is going to be dominant over 3 to the x graph. So although in a big picture, 2 to the x is going to be bigger, but you have to be careful when it's going to be definitely bigger. And that's the part that I want you to be careful about each functions. So before we start the rational function graphs in next one, let's review our general form of the rational functions. We have 1 over x as a rational function, which is odd, and then this is going to be even function of the rational function. So as we saw, y is equal to x as an odd power function, our graph was this way, right? And if you guys did the graph part of the first 1.1, then you will remember the graph shape will be this way. And I want you to plug in points and double check as well. So from here, what do I have? My domain is going to be all real numbers, but 0. Range is going to be also same idea. I can plug in any numbers, and then you're not gonna get 0 as an answer. This shows that it's going to be odd function. Odd function means you can rotate it 180 degrees and shape is the same. Then asymptote, I have a vertical asymptote at x is equal to 0, and then horizontal asymptote at y is equal to 0. Then what happens if I have a 1 over x squared graph? Even function, we have a graph on quadrant number 1 and 2. This is going to show in a similar way. So we are going to have our graph by plugging. You can also plug in those coordinates. So 2, 1, 1 half, then 2 gives you 1/4, 1, and then that's going to be 4. So graph carefully, they are slightly different. And then if you plug in -2, that will make positives. So this time it's going to turn out to be even function with my asymptotes are here. Domain is going to be, as you see, the same. Range is the same. Even odd function, this time it becomes an even function, which is symmetric over y-axis, and then asymptote is going to be same as the next one because it passed through x-axis and y-axis. Okay, doing good. So we are on now dessert questions, and today we are going to introduce a little bit of a pre-cal material. Before we do, let's see if you guys remember the graph of this one. So I'm going to go quickly, and then if you also can do together with me, try to recall how we can graph and then what are the properties we need to find. So in order to graph this one, actually I wrote it down the step here. So you need to find the domain and then factor. We are going to find vertical asymptote and horizontal asymptote. And then definitely we need to find x-intercept and y-intercept, and then check if anything is crossing the intercept, or it's gonna be what will be the end behaviors. So try to remember those steps. If you break it down these two each, it will be nice to remember. So let's start it from number one. Find the domain. In order to find the domain, I can factor out carefully this. So I can have all real numbers but 3 or negative 3. Negative 3 or 3. And number 2, here said find the vertical asymptote. Do you guys remember how we find vertical asymptote? Vertical asymptote, you take 1. Do you guys remember how do we find vertical? Do you guys remember how to find vertical asymptote? Vertical asymptote will be whatever makes the denominator 0 after reduce. So in this time, my vertical asymptote will be x is negative 3 and x is 3. Because that makes this one 0, that you cannot have a value, so it's gonna block with the vertical asymptote. And 3, horizontal asymptote. Horizontal asymptote is we find by long division. This one is denominator. How to find it? So if I take long division, 1 divided by x squared, definitely you are going to get 0 as a quotient. So my asymptote is 0. Now I'm going to find x and y-intercept. X-intercept means y is 0. So by plugging 0, I'm going to have 0 over 1, and cross multiplication will give me, so 1 over x squared minus 9 is equal to 0. And if you cross multiply, I get x squared minus 9 equal to 0. Therefore, x is 3 or negative 3. Right? So I get 2 x-intercept, 3 and negative 3, 0. Nothing is across. X-intercept means y is 0. So it's not y is 0. Oh. Okay, so now let's find x-intercept. X-intercept means y is 0. So I'm going to plug in 0 is equal to 1 over x squared minus 9. Carefully cross multiplying 1 is equal to x squared. Oh no, 1 is equal to 0. What does that mean? That means I'm not going to have any x-intercept, because as you see, the equation is going to be not working. That means you're not going to have x-intercept. Then let's continue y-intercept here. Y-intercept means x is 0, so plug in 0 for this, then I'm going to have 1 over negative 9. And we need to see if this function is crossing anywhere. So this function is crossing anywhere. Let me explain this one after I draw these 5 informations. So domain and then horizontal asymptote and vertical asymptote, and we don't have any x-intercept, that means nothing is gonna touch, and then only have a one y-intercept at right here. That's all the information they gave it to me. Then I wanna see if my graph is gonna actually cross the asymptote, but we checked that it never gonna cross the x-axis. So in this case, nothing gonna cross your borderline here. Then how are we gonna graph with only one point? We have to actually use deductive reasoning in here. So when I look at this, I know that none of it is gonna cross, none of it is gonna cross, because they showed me that there's no x-intercept, no y-intercept. So this graph only have one options. This is the only way you can draw here. Because if you wanna go upper part, it has to cross, but we show that there's a none is crossing, which is showing by here, no x-intercepts. None of the graph will touch here. Then what will be other side? That's the part that we just have to plug in points. So I'm going to plug in 4. Let's plug in 4 here. Then f of 4 is going to be 1 over 7 times 1, which is 1 over 7. So when I plug in 4, I got this number. However, same thing. It's not going to cross here. It says never crosses the x-axis. So only graph shape I can have is this guy. I'm not sure it's going to be even function, odd function. So let's plug in another coordinate, which is going to be -4. I'm going to plug in -4 and then see that what you are getting here. So f of -4 is going to be 1 over -1 times -7 is again positive 1/7. Oh, that actually shows that this is odd function, and then with the graph shape this way. So remember, it was a long procedure to graph, and then there are 6 steps. Now I wanna actually graph this one. So what is the differences? Now we are in calculus. So that's why I put it this one as a dessert. What if we change to plus? Let's go over all of those information we need to find. So when I look at the domain, what makes this 0? Never. That means my domain will be all real numbers, because there's nothing we'll have as vertical asymptote, because none makes 0. Then number 2, I need to find vertical asymptote. How we find the vertical asymptote? Whatever denominator 0 after reduced, but it doesn't have anything makes denominator 0, so we are not gonna have vertical asymptote. So we have no vertical asymptote. It'd be weird, right? Number 3, then do I have a horizontal asymptote? Yes, still you have a horizontal asymptote, which is long division 1 divided by x squared plus 9 will give me, again, 0 as your quotient. You cannot divide it, right? And then number 4, my x-intercept. X-intercept, if I plug in 0, again, it's going to be 0 over 1 is 1 over x squared plus 9. 0 is equal to 1. It doesn't work as a function, so you have no x-intercept. And 5, this time y-intercept, where's it going to be y-intercept? That is equal to x is 0. If you plug in, you see that I gonna get 1/9. At least I got one number. And then number 6, we know that there's gonna be no crossing point because of horizontal asymptote y is equal to 0. And then when we check, same way of checking this one, there is no crossing point. Sometimes what am I talking is your graph can cross your asymptote, and those are the coordinates I try to find. So there's no crossing. Then how are we gonna graph this? Well, here's at one point, which is a 0.9, 1/9, very small. And think about this one. If I have x squared plus 9, everybody know that my graph is gonna look like this. But what happens if I make a reciprocal of that graph? What happens if I make reciprocal of a graph? Then your graph actually bend the opposite direction. So in this case, your graph is going to be bended. But as you see, nothing is going to cross the horizontal asymptote, prove that no crossing. So my graph is going to look like this way. If I draw a little bit big here, your graph is going to look like this way, and then you can put this one as 1/9. And it's very weird rational function graph. But if you really think about, you can see that if it was a +9, it should be open this way. But because of +9, there's no way that you will have y-intercept here. So in this case, that's gonna be curved back again, because there's no denominator makes 0 in this case. Okay, so I want to compare these two, just changing plus to minus, how much it changes in here. How much it changes here. As you see, the graph is totally different. Compare, domain are different. Asymptote were same, but graph also totally different. And then as I mentioned, they are not even similar at all. We are almost done. We are on last question of 1.6 and example 5. Let's review how we're gonna graph the rational functions using the step we learned. So in order to do this one, it will be easier if we can factor. So if I factor this one, it is going to be 3x and x, 1 and 1, and it's going to be plus and minus, and check for me. Over denominator is going to be 2x and x. It's going to be 2, 1 minus a plus. I think this works, right? So that's my factor form. Nothing is reducing that we do not have a whole. We are going to talk about whole very bottom. So domain is going to be all real numbers, but 1/2 or -2. Then now we have a vertical asymptote will be x is equal to these two numbers, because you cannot have those values that they are going to make up borderlines. And horizontal asymptote I've been mentioned, long division. So try to see that if you divide 3x squared divided by 2x squared, how many times it can go in? It can go in about 3/2 times. If you multiply 3/2 to the 2x squared, do you see that there will be 3x squared and cancel out? So my quotient is going to be 3/2, which is going to be your horizontal asymptote. Some of you guys will probably learn different way too, by comparing your leading power here. That's another way you can do when it's this kind of same degree function, top and bottom. Then horizontal, vertical asymptote have to be found. Let's find the x-intercept. X-intercept means y is 0. So I'm going to set y is 0. And by cross multiply, I'm going to have 3x plus 1, x plus minus 1 equal to 0. So, I'm going to have two x-intercepts, which is going to be -1/3 and 1. Let's find y-intercept, means y is 0, x is 0. So let's plug in x is 0. Then this all cancel out that. I'm going to get 1/2 as a y-intercept. So far, let's put those informations, and then we can check anything crossing at the x-intercept. So horizontal asymptote. So vertical asymptote is at positive 1/2, and another one is at -2. Horizontal asymptote is 1.5, And then luckily we have 3 points in this time. So the coordinates that I have is negative 1/3. Oh, that's a nice point. And then I have a 1. Oh, that's a nice point. And then y-intercept at 1/2. Interesting. So I got those 3 points and fill up those 5 informations. So we need to see if my graph can cross here, which means that this can be this shape or could be come down, but I can see that it will go up there, right? With a kind of a direction of the point. So let's how we gonna evaluate what number is gonna cross here. That means my function has to be same as 3/2. So I'm going to copy 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2 has to be equal to passing y value as a 3/2 because I want to find x value when it passed through 3/2. So we're going to do cross multiplication quickly again. That's going to be 6x squared minus 4x minus 2 is equal to 6x squared plus 9x minus 6. Canceling out, moving the coordinate to this side, that makes it 13x is equal to 4. Hopefully I didn't make a mistake. And x is equal to 4/13. So they are saying 4/13 is gonna pass through. I feel like that's right here, this point. So when you have 4/13, it will pass through 1.5 at 1 point. So I only have 1 point crossing it. That means we'll be almost done. The graph shape has to be this way, no other options. This one, since it never crosses this one, I must have a graph only this way. Then we have 2 choices this side, either number 1 or number 2, which we don't know. So we gotta plug in by testing point. I'm going to plug in -3 and then what I am getting. So let's plug in -3 in here. -3 times 3 plus 1 is going to be -8 times -3 times minus 1 is -4 over bottom is -3, -2, -6, -7, and then -3 plus 2 is -1. So if I compute this number, it's going to be 32/7, which is about 4/7. So I know that if I have a -3, it's going to be bigger than 4. So it has to be passing through this coordinate, then my graph is going to be turn out all 3. Okay, I hope that this was a good review of graphing it. And there's one question for you in class activities. Let's try to pause it and then finish it so that you can compare the answer with me. Okay, I hope that you get to finish in class activities and compare the answer with me. So if you look around, I tried to put some work for you. Sorry, it's all over. So there's your domain, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. And then when I testing, if it's a crossing at vertical asymptote, if there's any graph meets there, which will be give me y value is 2, it actually didn't work. There was no x value existed, so there's going to be no crossing. Okay, so that's the answer. Now, if you look at the bottom part, I want to actually discuss about those 2 questions. What happens if you have x squared minus 1 over x minus 1 as a function? As you see this one, we can factor x plus 1, x minus 1 over x minus 1. Did you notice that actually cancel out? If we cancel out, then what happened to my graph? Still, it's going to be x plus 1 graph, which I know, graphing this way, y-intercept 1, slope 1. However, as you see, I cannot have a 1 as input. So this will have a hole at 1 because I cannot have that as my input. So my graph will be look like this way. So that's how I want you to see the comparison of when you have x plus 1 and then when you have a rational function with reduced and then when you get x plus 1. That's the differences. So I want you to do one more with the ICA. I wrote it r is equal to x over x. What is going to be the graph? That is going to be, again, I know that it's going to be 1. Then the graph shape will be just a horizontal line as y is equal to 1. However, what is the value I cannot have? Where should I make a hole? I have to make a hole at 0 because I cannot have a 0 in here. So this is the graph of a rational function when your equation, when after factor, it reduces. If it reduces, then that moment becomes a hole. Okay, so that's it for this week, and good luck with doing homework. Everything is due on Monday, so please turn on yours by Monday. Even I will try to make week 0 adaptive practice due Monday as well, so that you get to do this week a little bit more practice. Okay, good luck catching up. Good job.